would say let's start. It's been 2 minutes since the official start of the meeting, so I think we are fine. So, welcome everyone. My name is Daniel, and today we are here in our OL Network weekly community call, and I am happy to be the host of the session. Before going further, I have to remind everybody that our call is recorded, so please keep that in mind and act accordingly if necessary. Every week in our weekly community meeting, we will have a roundup of all the working groups. We will hear about their activities in the past week, and usually we have a guest speaker. Today, we are blessed to have an exceptional guest, the creator of the Move language and the CTO of our network partner, Mission Labs, Mr. Sam Blackshear. As some of you may know, the OL Network Smart Contract Programming Language is Move, and having Sam here with us as the creator of the language is such an exciting event. Sam, I don't see you in the call yet, but welcome. And so, in the first part of today's meeting, together with Rico and Shashank, we will give an overview of our activities. In the second part of the call, Sam will talk about the Move language. And in the last part, we will open the stage for our members to raise their questions. Okay, so where are we now? Today, it has been 144 days since we opened the project to the world, and we are at epoch 162. As of right now, we have 81 validators in the active set, and our active miners increased by almost 200 to 1,649. Since last week, we have 3 significant pieces of news to share with our community. First, our governance working group has prepared a constitution and governance proposal draft that is available for everyone to review in the governance working group channel in our Discord. Second, we have a new Carpe release out. If some of you are new, Carpe is our blockchain wallet and miner application. So please check it out and give us your feedback on this new release. Third, the work on migration to DM 1.4 has begun. Version 1.4 is the latest one, and in the next few months, we can migrate to this new version. All right, so Rico, I will hand in the stage to you and let us hear about our working group's activities.
Yeah, I'm going to cover, thanks Daniel. I'm going to cover a couple of the working groups. Christian wasn't able to join us today. He's got a conflict in another meeting, so I'm going to pick up some of his cover today. So the first thing is the Hustle Karma working group. The Hustle Karma group met as usual. We meet on Tuesday mornings for those of you who are interested. It was an end of the month time, so we were trying to make sure we got end of the month reports and roundups done. Those are starting to come in now. Hopefully next week we can give you a full report on the flow of coins through Hustle Karma in March. In the meantime, if you keep an eye on the handbook, all of the Hustle Karma monthly reports are posted into the handbook, so it's public. All the information's out there. If you're interested, you can always dig in. Then you can always ping me or Red Devil. We're key members of the Hustle Karma working group, and we can help you find that information if you're looking for it. One of the other big pieces of news that came out of the meeting this week is we finally landed the payment amounts for the working group key roles and for the community manager. So I think at this point in time, all of the sort of recurring work roles, the moderators, the working group key roles, the community manager, those have all been set up with a payment mechanism, and payment amounts have been established and a source of the funds has been established. So that's really great to see. We've been promising that for a while, and it's good to finally deliver it. We're also raising the compensation for moderators this month. We did sort of a level set with the various compensation amounts, and this is something that's an ongoing conversation with that Hustle Karma group. So again, if you're interested in that sort of stuff, show up there. That would be great. We also talked about some of the new volunteers that have come into the group, some of the new bounties that have been posted as well. We are looking for a community recruiting manager right now, if anybody's interested in that job, trying to scale up and build up our talent base. So again, Hustle Karma as usual, a productive group. Things are moving forward over there. Again, join us on Tuesdays if you like. The second group that I'm covering today is the Branding and Comms Working Group. Branding and Comms, last week we went through the next round of revisions on the logo ideas. We've landed 2 general ideas. One of them is very, very close. We just asked for a minor revision to the typography. The other one, we weren't able to arrive at a consensus on the exact design, but we agree on the theme. So Elliot, who's been the superstar that's been working on this for us, is going to provide us with revisions of those things, I believe today. And that meeting, by the way, happens right after this meeting. So hopefully we can land that. Our goal is to get this to 2 different ideas that we can propose to the community, and then the community can pick which of the ideas we're going to go with. They're both cool. I think we're in good shape on this. Second, we finalized the new member orientation deck and content, and we gave our first new member orientation last Friday. Kudos to Danielle for helping with that, and to BCMO for helping with the design and the execution, despite being deathly sick with COVID. So kudos to both of those guys. And we're going to be doing those new member orientations now every month on the first Friday of the month. So that's actually a new mechanism for the community, which is great. And then the last group that I'm covering for today is engineering. I'm covering for Christian there. I was able to drop into part of that engineering working group as well, and was super excited to hear from Coin 1111 that he's finished the coin transfer mechanisms on both sides of the OL to Ethereum bridge. Needs to clean it up and refactor it a little bit, but at least from a CLI perspective, it works. We had a long discussion about potentially utilizing a multi-sig module and what would be the sequence of those events. And then there was quite a bit of talk about, whether Ethereum was really the right destination, if you will, for that bridge due to cost. And so the team did have a conversation about other EVM compatible chains, with some favoritism shown for the Binance ecosystem. I know we were trying to rope Zucky into that conversation, but Zucky was in a conference at the time, I believe. So heads up, Zucky, that debate is going on with engineering right now. We also talked about the make whole. We have a discussion ongoing right now about the modality to use, or if you prefer, the method by which the Carpe miners can claim the due amounts. What we would like to set up is we'd like to set up that something that actually requires the Carpe miners to take an affirmative step, even if it's just clicking a button inside Carpe to claim the amount. Because that would force Carpe miners to upgrade to the current version of Carpe. It would also probably get some of the stale miners back into the system, etc. And it's just more engaging than simply blasting out the coins, some of which are going to go to stale wallets, right? You know how it is with early adopters. That was the end of the engineering working group summary, and I think that pretty much covers everything from that group. We spent a lot of time talking about the bridge and EVM compatible chains, and a little bit of time talking about these mechanisms for the make whole. I think that's it. If I missed anything, Shashank, you were at all of those meetings except for Branding and Comms, so let me know if I missed anything. And with that, Danielle, I will hand it back to you.
Thank you so much, Rico. And also, many thanks for all of your works in the past few weeks. I really enjoyed our session for the orientation meeting, and I really suggest to all of our new members to join the next session, which will happen as the first Friday of each month. So I would like to give the floor to Shashank to give us a brief report about the governance working group.
Yeah, thank you. So I am covering the minutes for Christian, who is the archivist for the governance working group. And in the last meeting for the governance working group, as you might have noticed, over the last few weeks, we have been discussing about mechanisms to ensure that the governance process is including the broader community. And there have been quite a few issues about the problem of identity and contributions before adding it directly onto Discord. So Rick had come up with a proposal on an interim voting or governance process with network steering council, and there are some details which have to be weeded out, and the particulars are still being worked upon. But there's a proposal floating around in the governance working group channel on this particular proposal. There's also a discussion which was about the constitution or charter for OL, which is supposed to set out the guidelines or a lightweight, like the rules, which we wanted to adhere to in terms of conflicts, so that the initial discussions on the constitutions have kicked in, and we are trying to get the first draft out, both of which would be discussed again during this week's meeting. And we might soon try to propose this interim governance process for the broader community in the community core. That's it from the governance working group.
Awesome. Thank you so much, Shashank. And welcome to Zaki and our guest, Sam. Very excited for today's call. Before we hand in the stage to our legendary guest here, on behalf of our analytics working group, I want to discuss one note, and that is a call to action. Our analytics working group needs to have more contributors to move things forward. And most importantly, the vision is that we want to have a self-sustained working group there. B and MZ, who are the coordinator and the archivists of the analytics working group, are experts in this field, and they are doing it as their full-time job and business. But their availability is limited, so they told me that they are really happy to teach anyone interested in this field, to help them in the analytics working group, and also teach them to learn about these areas. So, and also there are lots of ways to contribute to this working group. So product management experience to break down the hustle karma tasks, data science skills, data engineering, data visualization, and communication are ways that you can do that. So if you are interested, please take a look at our analytic working group channel and share your thoughts with us. We are a community-driven project, and we'll be happy to help you grow with us. All right, Sam, I am really hyped for our session today and really looking forward to hear what you've prepared for us. And please, the stage is yours.
Thank you so much for inviting me. I'm super excited to be here and get to speak to all the great Zero-L folks about what's going on in your community and to talk to you a little bit about Move. So there are really two different things that I've been asked to talk about today, or that I'd like to cover. Please feel free to interrupt me in the middle of either of these with questions or clarifications. Then there'll be lots of time at the end for even more non sequitur questions not related to any of these topics. But the two big top line things that I wanted to cover were to go a little bit deeper into the origin story of Move, which I think is something that we haven't written or talked about a lot publicly, basically how it came to be, the problems that it was designed to solve, and sort of how our thinking on that evolved. And then the second thing is sort of jumping way ahead from the origin to today and to the future, but I want to talk a little bit about how I see Move's place in crypto today and my vision for the language and its role in Zero-L, in SWI, and in crypto more broadly. going forward. So for the origin story of Move, let me actually start by telling you a little bit about my background and basically, how I came to be working on Move and in the crypto space. So I'm a programming language theorist by training. I did a PhD in static analysis. My research is on building scalable automated bug finding tools. And I did that both in my PhD and at Facebook for many years, especially on this. There's a tool called Infer that's a multi-language static analysis framework that does all sorts of cool automated bug finding stuff, like the basics like null dereferences and index out of bounds. But we've also worked on data race detection, on taint analysis for checking that input that goes into, say, an endpoint that comes from a user doesn't flow to SQL or the shell without being escaped first. And, just any of these cool things that you can do with static analysis and automated bug finding. So the way my background is all about thinking about safety, thinking about languages and how they can go wrong, thinking about how to design languages and programs in a way that makes it easy for automated tools to detect bugs and for end users to reason about their programs and for programs to compose well. For when you have two programs written by different people who never anticipated their programs talking, how do they continue to work in the way that the original authors expected when you do this composition? So I've been working on this static analysis stuff for a while, and I really love the work, but I just developed a lot of opinions about language design based on my experience of trying to basically band-aid existing languages and frameworks via analysis, which is what we did a lot of at Facebook. And so in 2018, I got the chance to put some of these ideas to work when I heard about this Libra project that Facebook was starting up. This at the time was this big top secret project to build a global scale payments network that was based on blockchain. And they were pulling in folks from all across the company in the areas that they thought were relevant. There were cryptographers, there were distributed systems people, there were payments experts, and then of course they cared about languages as well. So they asked me basically, these platforms, like the programmability is an important aspect. There's this smart contracts thing, like take a look at what's out there and basically figure out what we should do. Like you can take the existing languages and try to make them better. You can design your own thing. You can try to retrofit a general purpose language, just study the problem and understand what we should do here. And so this is what I did along with a lot of the other folks who are working on this project. We mostly weren't, this is early 2018. And so the crypto space itself was somewhat nascent. Like, Ethereum and Bitcoin were basically the only game in town. And also like we were just all trying to figure out how it works. So from the language perspective, I looked a lot at blockchain and tried to figure out the things like, is proof of work fundamental? How does consensus fit in? How does this other stuff work out? And we ended up thinking that actually most of this stuff is not so relevant from the perspective of the smart contract language. From that perspective, you can think of blockchains in a very, very simple way, in a classical way of this replicated state machine abstraction. So replicated state machines are this old familiar concept in distributed systems. The idea there is, okay, I have a bunch of computers or agents that are interested in agreeing on the state of the world and then processing computations and continuing to agree on the state of the world. And the formalism is just that if everybody agrees on the initial state and they agree on some state transition function f, and that function is deterministic, then they can process messages that conform to that state transition function, and these machines will continue to agree on the state going forward. And so this is a delightful and simple way of thinking about the world. And if you think about that perspective, smart contract language just is this transition function f, and then what a smart contract is that part of the state that state machines are replicating includes executable code that can be called from this f function. So this perspective is useful because it gives you some what I like to call table stakes requirements for smart contract languages. There are properties that if the language doesn't at least satisfy these properties, then there's just no point in using it in this setting. So the first one, which I already sort of mentioned in passing, is determinism, where if you don't have deterministic state transitions, you can't be a smart contract language because it undermines this whole project of making sure that everyone agrees on the state. The second one is this notion of gas metering, right? In these blockchain systems, folks are accepting transactions. You want to let everybody send transactions and have the system keep making progress. So it wouldn't be appropriate if someone sent a transaction that ran forever, or even a transaction that doesn't run forever but consumes some unreasonable amount of resources. This is also something that you don't tend to see in mainstream languages, but is very, very important in this setting. And you can't just use timeouts here because, again, like we need determinism, and timeouts aren't going to be deterministic across different machines. And then the final table stakes requirement is that you need type and memory safety, and you need this at the executable level. It's not enough to have it in the source language. If you have a source language that has some nice type and memory safety enforcement, like say Rust, but then it compiles down to machine code or some low-level language that doesn't have these protections, an attacker is just going to write their code directly in that low-level language and bypass all the nice protections you have. So whatever protections you're going to provide, you really need to provide them at the level of what actually runs on the blockchain or in the replicated state machine. So the interesting thing about these table stakes requirements is that pretty much no mainstream language satisfies them. Like even determinism, you would think that this would be a common thing, but pretty much every language has hash tables. If you iterate over a hash table, that's going to be non-deterministic in most cases because it'll leak the details of how the language is laying out the hash table in memory in a way that's not deterministic. Similar for gas metering. This just isn't a very common thing to do in mainstream languages. And then the type and memory safety enforcement tends to be at the source level because the point is to prevent the programmer from making mistakes, not to protect them from malicious adversaries who are going to call the programmer's code directly. So this line of thinking made us a little hesitant to try to retrofit an existing mainstream language, although that was our initial instinct. You really don't want to invent a new language if you don't have to. The ecosystem effects and the tooling and the battle hardness of existing mainstream languages are so powerful that you'd really like to be able to use those if you can. But the problem is if you want to use one of those, and we looked at retrofitting the JVM with this stuff. We looked at retrofitting WASM. We even looked at retrofitting Skylark, which is this build language used at Facebook and elsewhere that has some nice determinism properties. If you try to do this retrofitting, you end up with this nasty kind of hybrid where you restrict the language to get some of these properties that you want, like you restrict it to get rid of non-determinism, and then you have to extend it with something like gas metering because it doesn't have that, and you end up with something that's very, very hard to reason about, and that ends up undermining a lot of the goodness of using an existing language. If, say, you want to restrict the language to be deterministic, okay, you have to ban the usage of hash tables. It's fine to write a little build system that does that, but now you pull in a library. How do you make sure that some dependency really deep in the tree isn't using hash tables somewhere or using them in a way that's not deterministic? And then you end up just being able to not use a lot of existing libraries and tooling, and the whole point of using an existing language goes out the window. So that basically convinced us that this wasn't going to be a productive line of inquiry. So then the next thing, of course, to do is to look at the actual smart contract languages that were out there. And at this time, there was only the EVM and Solidity that were basically the only game in town. And the big thing that was on everyone's mind was safety issues. The DAO hack had just happened. Everybody was talking about this. And reentrancy seemed like it was the thing that was really the big problem with the EVM and with Solidity. And if we could solve this, maybe it would be okay. So we looked into this a little bit, both the DAO hack specifically and other hacks that were going on. What we ended up thinking is although this is a problem, really this is a symptom of a much broader problem, which is that EVM, and I think this was true for the EVM at the time, but it continues to be true for other smart contract languages besides Move that have come out since then. They just lack the vocabulary to describe the kind of computation that smart contracts want to do. If you look at what smart contracts do and what distinguishes them from normal languages, they're all about defining assets and then defining logic for moving assets, authenticating the user who's supposed to have the assets, doing some permission checks, and making sure that these things behave the way you'd expect physical assets to behave and that the authentication logic is correct. But despite the fact that the use cases for these are asset centric, there's just no vocabulary for assets in the language. For example, in the EVM, you can't pass an asset. You can't return an asset from a function. You can't store an asset in a data structure. You can't even have the asset leave the contract that's defined it. This just makes life really difficult if you're trying to build up these nice towers of abstraction like we do elsewhere. The way you do things in a normal language is I have some type or an object, say I have URL, I have some enforcements on the structure of that thing. Maybe I check the well-formedness of the URL. Someone can pick up that type and use it in their application or use case, and they add some additional constraints on top of it. They add more abstraction, and then all of a sudden, we're up at the highest level of abstraction, and I'm using a web server type and not having to worry about what goes on in lower layers because everyone is just gradually built up. If you don't have types, you can't build up you can't do this sort of thing that we always do. You can't build up these nice towers of abstraction and the safety that you would have. And so really this seemed like a fundamental problem with the EVM. I mean, you can do this locally. To be clear, you can do this locally within a contract, but the problem is you can't have types that are reused by a different contract that doesn't trust it, and you can't have assets that flow across contract boundaries without losing their integrity. So in designing Move, this was really the key problem that we wanted to solve. And when we looked at something like the DAO hack, we said, yeah, well, reentropy is an issue here. But the real problem is someone is trying to implement an asset that has, this nice integrity property, and they failed to do so properly because reentrancy made it hard. So why shouldn't the language give you give you a type that buys you that integrity for free, and then each programmer doesn't have to worry about re-implementing it themselves and dealing with the safety issues that arise. So basically, that's what we did. We drew on this concept of linear logic that came way back in the 80s from a cool logician named Jean-Yves Girard, and then this has been brought into the programming languages space by folks working on linear types and or substructural types, and most prominently in Rust, which has this notion of memory and borrowing that's very much based on substructural types. So we took a lot of that stuff in Move, and we just tried to, and what we did is basically define a bytecode language where all that type system works at the bytecode level instead of at the source level. I mean, we have a source language as well, and we check the properties there, but that's the thing that we were trying to do. And this ownership and borrowing discipline is very natural for assets. Just like in Rust, if folks are familiar with it, there's a concept of an ONT where you have full privileges on the asset. You can transfer it, you can borrow it, you can mutate it, but when you transfer it, you will no longer have it. The person you transfer it to will have it, and the type system enforces that. And similarly, we enforce these properties around non-duplication. If you have something like an asset, it won't do to be able to let somebody copy it. You have to make sure that even though under the hood it's just bytes, you have to make sure that someone can't copy some bytes and then reinterpret those as an asset or make two copies of some existing thing that they have. So these are all the things that we were trying to do. And originally the way we did this is that we had a difference between ordinary struct types like you'd have in a normal programming language that allow things like copying and being in multiple places at once and all this stuff. And then these so-called resource types that have all these protections. But over time, we've decomposed those a bit, where we have this ability system where by default, structs don't have permissions to do things like copying or being stored in global storage, or the ability to be dropped indiscriminately without calling a destructor. But now you can tag your type with these abilities. And so this lets you decide, instead of just being a struct or a resource struct, you can mix and match these properties to have types that behave very differently, which leads to a lot of cool things. So I think that basically covers the first thing that I wanted to talk about. Talked mostly about the problems with, or how Move came to be, and sort of the way we're approaching the problem. I could talk a lot more, of course, about how the language design evolved from our initial thinking, or also move on to part two. But I think this is probably a good time to pause and ask for questions on the first bit, because I've covered quite a bit of things.
Thank you so much, Sam. It is so cool to hear all about the history that made the Move language come to life, and from the DAO hack to Libra project and your background and PhD thesis in the areas that is fundamental to programming languages. And I would like to ask our community in the call that if they have any questions, that feel free to raise their hands, and also our panelists here today as well. One area that I was thinking about Move is the problems that exist with the Solidity language. And I think one of them that you mentioned is about not being really resource-oriented. Am I right?
Yeah, that's exactly right. I mean, I think this is one of the hardest things about programming Solidity. It's both a safety issue, which is most of what we were thinking about when we designed Move, but I think I've come to understand over time that it's just as much of an expressivity issue. Like now, a big thing is NFTs, and folks want to do something like, I have an NFT that's a parent of another NFT, and the natural way to express that is something like, you have the parent that's a type, and you have the child that's a field of that type, and then this is a very natural thing to write. But in Solidity in the EVM, you can't express this because the parent is going to be an NFT that lives in one contract. The child is going to be an NFT that lives in a different contract, and you have to express these relationships via some sort of indirection, like you have a third contract that talks about the parent-child relationship, and then it has pointers into the big mappings of those Solidity contracts. And you can do this sort of thing, but it ends up being very cumbersome to write this sort of code, especially because like with the DAO hack, you have to atomically update the entries in each map. And then also for something like NFTs, if you have to standardize this kind of behavior so that folks know how to interpret the parent-child. Everyone has to agree on what the parent-child relationship looks like, so they can so other contracts can interpret it and know generally how to do this. Whereas in Move, you just write the types and then everybody understands it by default. There's no need to agree on some standard in order to do these sorts of things. So indeed, like this is one of the big things we were trying to address, and I think the benefits of it were both the ones that we anticipated, but also ones that we didn't think about that are becoming more clear now.
That's really cool. So, yeah, it is. I think because of the nature of its nature that is resource oriented, it also results to be quite safer than what Solidity provides, I assume. Because that way, the issue with inheritance that we have is basically goes away, and we always have one estate for just one resource.
Yes, that's right. And the resources are one big part of the safety improvements. There's another one that we talk about less, but I think is equally important, which is the absence of dynamic dispatch. So there's a saying that we like to have on the Move team, which is, in a world where code is law, interfaces are a crime, or dynamic dispatch is a crime, or however you want to phrase this. Where basically the idea is that if you have some code that involves money, and if you have something like an interface, right? Like this means that it gives you no guarantees about its behavior beyond the type signature, and in the EVM there are no types, so your guarantees are very weak. It's a kind of a crazy thing to do, to just write code that calls that and assume that everything's going to work out well. You can do it safely, but you have to be very, very careful to do so. And issues like reentrancy, I think, are a symptom of the broader issue of that it's just not very safe to have something like, say, ERC20 transfer be a dynamic dispatch call. It gives the program a lot of expressivity in deciding what the transfer can do, but this also means things like poison tokens, where someone sends you a coin and that the act of selling it or sending it to a DEX steals some of your other coins. This is all possible because the most basic piece of functionality, like transferring a token, involved dynamic dispatch. And in Move, we don't have that feature at all. And that just means that things like transferring a coin, it always does the same thing, no matter what the coin type is, always has the same gas cost. Things are very consistent across all implementations of something, which both makes things safer and then gives you a way to have that expressivity, but without having the safety of having a dynamic dispatcher interface in the way. So you were talking about resources and being safe, which is definitely important, but I just wanted to mention one other facet that I think is also interesting.
So, so if you lack dynamic dispatch in Move, which I kind of haven't really thought through the implications of this very much, how does this how do you think in terms of does that mean that what statically verifies that, for instance, when you introduce a new asset, that transfers always does the same thing?
Yeah, good question. So I think it's easiest to talk through a specific example here. So let me talk about coin of T, which is basically our equivalent of ERC20, or is supposed to provide the equivalent functionality. Move has generics, and these generics aren't just a source level abstraction. They exist in the bytecode as well. And so there's this coin. If you look in 0L or in SWI or in any other Move power chain, there's going to be some type that looks like coin of T. So there's a module called coin, and there's a struct value that's also called coin. It takes a generic type parameter of type T, and the idea here is that T would be something like USD or ETH or GBP or whatever token you're talking about. And structurally, a coin is just a U64 value. That's how much is this thing worth? Coin then defines a function that's called then defines a variety of functions. So one says, if you have a mutable reference to a coin and you give me a number, then I will subtract that number from the value of the coin that you gave me and then return you a new coin with that value. It has a function called transfer. It's it takes a known coin and an address, and then it sends that coin to the new address. And this is the same code regardless of what that T is. It's the same whether T is GBP or USD or ETH or whatever else. So this is the reason why you don't need dispatch. You put all the dynamism in this example. You put all the dynamism in that type T, but then the behavior of the coin is the same regardless.
So like
And then
move, the way I think about it is like, for instance, if you wanted like a rebasing coin, that like where the balances like get mutated over time, it would actually be a different generic type. It would not be coin.
Exactly. It would be a different generic type.
Yeah.
And of course, you do need flexibility in some places. Like, different coins are going to have different minting policies and different burning policies, like to your point, the rebasing. So the way it works is that one of the functions of coin is register, and register register can be called only once, basically when you create the coin. And what it gives you is what's called a treasury capability for T. And the treasury capability gives you the permission to mint and burn coins of that type. And then you can wrap that capability in a different object that then enforces the policy that you want. If you only want there to be 500 coins, you wrap it in an object that only will let you call mint until the total supply reaches 500. If you want something like a rebasing coin, you do something fancier where you create a reserve and you lock the treasury capability in the same object as the reserve, and you enforce that rebasing policy there. So you just push the dynamism out to a different spot and then let the core functionality like transfer just be the same function call for every coin type. This is about coins specifically, but in general, like this is how you get dynamism and move. You use generics, and then you use these capability design patterns and the fact that you can wrap these to restrict access to privileged operations.
Yeah. It should be possible to instantiate coin of T on top of OL right now. And I think it's like one of the more exciting questions is like, who's going to be like the first person to like build something like this?
Yeah, absolutely. We have some examples in SWE of like different types of coins that you can build, like a basket-backed coin and coin with limited supply. And I think we're going to add a few others as well. But I'd love to link those and then to inspire the creativity of the ZeroL community. And I would love to see fancier stuff like rebasing coins or algorithmic stable coins.
Excellent. Thank you so much, Sam. I think we are also ready for your second part of the presentation or talk.
Great. Yep. Thank you for the questions. These are very good things to ask. Let me now move on to the second and final part, which is about how I see Move's place in crypto today and its role going forward. So I think almost everything I've talked about with Move today is about safety and expressivity. But really, having perspective since 2018, working on this and looking at the space, I think the most important aspect of Move is actually that it's fundamentally a cross-platform language. The state of smart contract languages today is basically that you have one every time you launch a new blockchain, and by a new blockchain, I mean something that has a fundamentally different architecture than ones you've seen before. You have a new language that comes with it, and that language is different from the ones that you've seen before. It doesn't have a community yet. It doesn't have tooling yet. It doesn't have smart contracts written in it yet, and folks need to learn that language to work with your blockchain. So this is not a good way to build language communities, because if you're a smart contract developer and we live in a multi-chain world, ideally I'd be able to develop for multiple chains, and I wouldn't have to relearn everything when I want to move from one to the other. The other thing too is that this leads to things like, okay, we have a lot of EVM developers, so every new chain we're going to launch is going to be EVM compatible or look a lot like the EVM, which is good for keeping those devs around, but it also means that this EVM compatible chain is going to inherit a lot of the design decisions and a lot of the limitations of the Ethereum platform. So when you have a language like the EVM, it overfits to things like the account structure. This is baked into the language itself. The transaction format, this is also in there. To some extent, the cryptography used and the consensus used. If you're going to build a new EVM-based chain, you have to take all these things, or you have to really do some rather nasty modifications to get rid of them. And, I don't want to say too many bad things about the EVM or Solidity. It's amazing the point that they've gotten to, the billions of dollars in Ethereum and other platforms, and the excitement and the innovation that the stuff is spurred on. It's very, very impressive, and it's very good stuff. And there are many things that are creative about EVM and about Solidity. And so I don't mean to be saying anything bad about this at all. But I do think now that really the presence of the or this meme around EVM compatibility and like the idea that the EVM is one and that's the only game in town is really actively holding crypto back. I think it's too hard to be an EVM developer. You have to be a security expert in addition to an expert in what you're building. The need for these really thorough audits to launch any smart contract based project, because the blast radius of what can go wrong with the EVM is really nasty. The EVM it's not fast. It doesn't look like conventional VMs that folks in the programming language community know how to optimize and make really fast and build tooling on top of. And I think it's hard to onboard developers. There's big financial incentives to become an EVM and Solidity developer. But if you look at the number of folks working in Web3 as developers, and my numbers here come from this report from Electric Capital. They estimate that there's 4,000 developers building on Ethereum and that there's 18,000 building on Web3 as a whole. This includes both smart contract developers and core protocol developers. These are tiny, tiny developer communities relative to the scale of web development or mobile development. These communities are hundreds or thousands of times bigger. Like I think there's 18 million JavaScript developers, for example. When folks say like, the EVM is one, or like, we have to make sure to cater to these other developers. To me, I really think the game is bringing in mainstream developers from elsewhere in Web 2 and giving them the language and tooling and other stuff that makes it easy to do this instead of needing to be a security expert and needing to go through an audit or learning this odd language. You want something that looks like what they're familiar with to the extent that makes sense, and then something that has a type system and like very opinionated guardrails in mind to guard them in the areas where they're going to need to learn new things, because there are some things that are fundamentally hard about smart contract programming. No matter how good a language is, it can't hide all of that. So I think where I'm going is rather obvious with this. Like I think Move is really the language that can solve both of these problems. Think of it as JavaScript for blockchains, not in terms of the language design, but in terms of the ubiquity. Like when you think about programming for the web, like you're going to be writing your code in JavaScript. Anywhere you have websites, anywhere you have web programming, you have JavaScript. And that works because JavaScript has the flexibility to be very cross-platform. You can use it in multiple browsers. It's very flexible in designing a variety of websites or web-based things without baking in its design decisions. Move can also do this. It doesn't overfit it doesn't impose things like a specific account structure on you, a specific transaction structure. It doesn't have any built-in cryptography. Whoever's building the platform can make any of these decisions for themselves. And I think they'll need to, because folks need to experiment with many different blockchain architectures in order to push crypto forward and actually get blockchains that are fast, that are cheap, that are safe. And we can't just stop with the architectures that we have now. So Move gives folks who are building new platforms the opportunity to try out these new designs without forcing them also to bootstrap a language ecosystem along with the very hard work they're doing in blockchain design. You can pull over Move developers from other chains. You can write your code in Move. You can experiment with all these sorts of things. And so basically where we are now is there's a number of chains. This cross-platform thing, it's starting to become a reality, but it's very, very early. There's a variety of chains that look very different under the hood using Move. So you have, of course, 0L and the very interesting stuff you all are doing with these delay towers and like taking some of the way Move originally worked in DM, where it had these very tight compliance controls, and you all have taken it and made it permissionless, and like also put in these cool features around fast wallets versus slow wallets and donations. Like these are all decisions you were able to bake into or Move didn't have to make those decisions for you. You had the flexibility to do that yourselves, and then someone else who wanted to do it a different way doesn't need to do it the same way as you. And yet you can still share code and share developer tooling and a developer community. And similarly, like we're doing this with Sui, we're using Move, but we look quite a bit different from DM and from 0L and the other kinds of things. We have a very different transaction model where the global state is a bunch of objects, and you explicitly declare the objects you want to take as input. And these objects are just Move values, and you write your code that way. And then you have something like Starcoin, which is this which looks a little bit like DM, but then is proof of work based and makes a lot of other decisions that are different from 0L and Sui. And then you have Aptos, which is also a little bit different from all of these. So all of these chains, I guess, are very nascent in terms of the amount of value in them and the number of developers. But I think it starts to show some early promise for this vision of, okay, you can really use Move in a variety of different settings and like be able to share code and tooling and build up a community. And so I think this is going to be a really key year for Move in terms of really getting a lot of both users onto the chains that are Move powered, but also like getting a lot of Move developers onto these chains. And I especially hope we can get some that are working across one or more of them at once without having to say like, I'm a 0L Move developer, I'm a Sui Move developer, like that we can share that kind of stuff. So I think this is a fairly short portion of the talk, but I think the vision is fairly big. That I can hope that if we're successful, folks won't be asking very much about EVM compatibility in the years to come. EVM will be more like the COBOL of blockchain, where like it's a very important, like it's an important piece of technology that underlies some of the legacy software and systems, but that for stuff going forward, like you really want languages that are safe. You want languages that are cross-platform and ecosystems that give folks the opportunity to reuse their expertise across many areas and to do so safely.
Awesome. I have two questions for you, Sam. So, coming from the view of an average software engineer or even a beginner developer who is interested in creating a smart contracts, do you think that the Move smart contract programming language is suitable for these people? And if so, how could they start and educate themselves in OL and perhaps SUI? And what are the prerequisites for them to begin with the Move language? And is it necessary for them to know the Solidity language already, for example?
So this is a great series of questions. I do think that Move is going to be accessible to average software developers and much more accessible than Solidity or some other things in this space. I think I definitely wouldn't recommend that you learn Solidity first. The main thing about Move is, I mean, it very much depends on where you're coming from as a developer, but I think this experience of writing in a setting where you have structured types, you can reuse these structured types across multiple modules. You have code reuse instead of copy pasting. You have a module system. I think these will be more, regardless of where you're coming from, and let's call it Web 2 or ordinary software development. This will be more familiar for you than it would be to start from Solidity. So I think the prereqs is just, it's good to know another language and then to come at Move from that perspective and then to understand the parts that are different about programming smart contracts. This idea of, okay, the security, instead of my philosophy to security being I have one endpoint and I hide everything behind a firewall, like the point is actually to write code that runs in a public platform where anybody can see it and anybody can call it, yet I still have to write it safely. So just to educate them about what does that mean for the way I have to write my code differently, to design it differently. Or similarly, like these restrictions on upgradability, that's something that's very different from conventional software development, where either you want smart contracts to be immutable or you want them to be upgraded in very limited ways that maintain the trust of the community, and that these upgrades happen less often versus, software you're writing for yourself where you ship releases whenever you want and can be more careful. So I think to answer your question about how folks should onboard or like the resources they should use, I think this is one thing that we haven't done a great job with and Move so far, and that we're really working on now at Miston and at SUI, and having a good series of tutorials and documentation to get folks started, and especially examples. I think examples are really the biggest thing here, because you can read language manuals until you fall asleep, but nothing inspires your creativity or like helps folks see how things work, like seeing here's how you implement an AMM and Move, here's how you implement, as Zaki was saying, a rebasing stablecoin, here's how you create this kind of NFT or that kind of NFT, just showing what's possible, both for folks coming from other smart contracts, they know how to like, okay, here's this thing I want to do, I know how to do it elsewhere, but also for folks coming from the mainstream, like this is what a smart contract is supposed to look like, or the sort of things that are possible here that aren't possible in the Web 2 platform that I'm coming from.
Great. And then I would say that anyone who is interested, that they should check out the Miston Labs documentations for the Move language. And also in OL, we also have some resources in our GitHub as well. And the second series of question is that you also mentioned that the vision of the Move language is that to become cross-platform. So I also remember that a few years ago when the Move language was introduced, two other blockchains, they integrated the Move virtual machine into their blockchain. And is it possible to use the same contract on OL or SUI on those blockchains too? And moreover, is it correct to assume that any blockchain that integrates the Move virtual machine, Move language, is still restricted by its own blockchain limitation, and the Move language could be the improvement in their ecosystem?
Yeah, so good questions on Solana and I think Flow specifically. So we had this cross-platform vision for a long time now, but I think there were a lot of difficulties from realizing it inside of Facebook. And basically, like inside of Facebook, like our mandate was to be very DM focused and to work on Move for that. So we had the cross-platform design in mind, but it was very hard to come up with commercial arrangements to work with someone to integrate the Move VM or to promote Move as an ecosystem. And this is also one of the reasons we ended up starting Mistin. Is just this is a better vehicle for doing this sort of thing. So for Solana specifically, they did integrate a very early version of the Move VM, and this was at a very early stage of Solana where they were looking for a high performance VM that could do some of the parallel execution stuff they wanted to do. I think this is an experiment that they tried, but they ended up going with the eBPF approach that they have now. It's possible that they could go back to the Move VM later, but I think this was an experimental thing that you cannot actively use. So someone from the Solana community could probably correct me, but I think that's the case. And similar for Flow, where they saw the Move white paper and they built a source language that was inspired by a lot of the features of Move in various ways, but they only had an interpreter for the source language. So for a while, we were talking with them about using the Move VM as their bytecode layer, and then we built a compiler from Cadence, I think is the name of their language, to the Move VM. I think that may still happen, but they just ended up having they've had a lot of success with various things, and the interpreter is working fine for what they have, so they've had other priorities. So that's about those two specific integrations. Although now we have a lot more like successful. The ones I mentioned before is Starcoin, Sui, Aptos that are actually using the VM. I think it's much easier to use Move if you're starting a blockchain from scratch than to layer it on top of something that's already made some different design decisions, because the Move really shines the most when you build your platform around it, I guess is the short of that. So then in terms of your question about can I use my 0L contracts or my Move contract or my Sui contracts elsewhere across multiple Move chains, there's always, the answer will often be yes. It sort of depends on the nature of the contract. Like as I mentioned, Move lets you make different choices about things like, say, account structure. So if you write a contract that relies on 0L's specific account structure and Sui has a different one, then you won't be able to reuse that contract. And these are the sorts of issues you have with code portability and conventional languages too. Like if you write code that it depends on the pointer size on one platform, it's not going to work on a different platform that has a different pointer size. So something that we're thinking about and working on a lot now is with guidelines for how to segment your code to make it maximally reusable. Like if your code is just doing math or cryptography, you should be able to write it in a way that it's absolutely platform specific. These are just common libraries that can be used across any Move chain. And then there are these sort of layers of compatibility. Like, okay, you can use this if your address, you can use this Move code if you depend on the address size, but not if you depend on 16-byte addresses, but not if you want 32-byte addresses, or you can use this code if you use this account structure that's common across a lot of Move chains, but not all Move chains, or these sorts of things. So reusability isn't absolutely a snap. There'll be some code that's reusable or some that's not, but I think it's important for us to have really good guidelines for the community and in how we set up even perhaps in the tooling and how we set up the package manager, that you could designate your code as like, this is supposed to be tier 1 reusable everywhere versus like, this is tier 2. And I use the following Move variants or features and it can be reused in chains that use those, but not in others.
A package manager sounds really cool to have. Since we are 5 minutes to the end of our session for today, I like to give the opportunity to our members in the call as well. So if any of you have any question, please feel free to raise your hand. And meanwhile, I like to thank you, Sam, for all of your nice presentation and talk that you did so far. And not only I really learned a lot in this session, but I also really enjoyed talking to you and listening to the history of Move and all the things that happened so far. So thank you so much.
Oh, well, thank you so much. I appreciate the chance to speak to you all.
Daniel, you mind if I jump in?
Sure thing, please.
Sam, thanks a bunch. Nice to see you again. It's been a while since we caught up. Hey, real quick question. Miston Labs was the very first partner for the OL network. So first off, thanks for that. But now looking forward, right, and hearing more about your vision of where Move fits into the broader system. Where do you think are the most productive areas that OL and Miston should work together and should focus on?
Yeah, Rick, great to see you again too. It's been a while, and great to be working together in this new context where we're both a bit more Web3 native than before. So I think the most important thing for Move, and this plays into the SWE Zero L connection, is that there need to be prominent Move powered chains. There are these chains, but and by prominent I mean both a number of end users, total value locked, and a number of developers on it. And I think the SWE and Zero L can work together productively on this by enhancing the Move developer experience, and especially like making sure that the code and development tools and the setup that that work for those are especially well aligned, and have a common set of docs, and just to make the community as portable as possible across those two chains specifically, in addition to the other ones that we care about as well. But I think given the alignment of the companies and the similarity of various things, that's the top priority for us. So I think this is sort of a grand way to. This is sort of a grandiose way to say it, but I think it's basically that, like, for both of us to help each other to succeed as much as possible. Like, the best thing for Move is for Zero L to succeed and for SWE to succeed. And then the way we work together on that is Move DevX and Move examples and building that common community.
Cool, that makes sense. Thanks a bunch.
All right. So thank you so much, everyone, for being here. Sam, thank you so much again. Really enjoyed your talk. And also our panelists, Rico, Shashank, Zaki. I appreciate you being here. And I hope to see you all next week. So bye-bye.
Bye-bye, everybody.
Thank you.